Hmm. So previous class we have seen that what is sorry. Let's continue with IP datagram format, and then we will come to routing. Okay, so I think this is the format of the IP datagram, or sometimes we call it IP packet also. So let's see those fields one by one. So let's start from the beginning. First, you see there is a field that is referred as VER. Okay, so it is a field of 4 bits, and this field indicates the version of the IP protocol. So obviously we are talking about IPv4 protocol. That means the value of the version will be 4 here. In binary it will be written. So this value will be constant for and will be same for each of the packet that is there. So it will indicate which version you are using. For obviously, if we are using if a sender is sending a IP packet of let's say protocol version 6, then this value will be 6. Then this is a field that represents the header length. Now, as the name suggests, this is a field that indicates the length of the header. Okay, length of header means this piece up to this. This is the point. This part is called header. Now, since this header may contain certain options fields, you see here these are the options fields. So a variable number of options may be there in this packet. So the total length of the header may be variable in nature. Now what is the minimum and maximum length? Let's see. Now this header length field is of 4 bits. So what is the maximum number that you can write here? Using 4 bit you can write 15. Now this 15 actually represents the maximum possible number of words that can be there. So here the length of the header is represented in form of word. A word means a group of 4 bytes. Okay, it represents a group of 4 bytes. Okay, so so you see that maximum value is 15, and each value represents 4 bytes. So 15 means 15 into 4. So maximum header length will be of 60 byte. Okay. Or what is the minimum here? The minimum length will be, since in case of no option is there, then this it will contain 1, 2, 3, 4, 5 words. So the value will be written here is 5, and length will be 4 into 5, that means 20 bytes. So the minimum length of this header is 20, and maximum length is 60. So these are bytes actually. Okay, so this is the field. Then this is a field that represents the type of service that this packet represents. Okay, then this is the field that represents the total length in bytes of the packet. So total length of the bytes packets means this length includes header length plus the data length. So that will be the total length. That means header length plus data size, you can say. So it represents both, the combination of both or sum of both, header plus data size. And you see how many bits are there for this field. You have 16 bits for this. So using 16 bits, how many different numbers you can have 2 to the power 16. Okay, so the length of this total packet maximum length will be 2 to the power 16 bytes. 2 to the power 16 का मतलब कितना हुआ? Around 65,535 bytes or 36 bytes, sorry. You can calculate just. So this is the maximum length of the IP datagram. However, IP datagram doesn't support, doesn't use this size of the length, because many times it is the case that the path that you are following may not support this large size. Then this is a field you see here. This is a 16 byte identifier. You can see this is a 16 byte identifier. Okay, so this field actually allows you to identify your datagram or the packet uniquely. So this packet is a provides a unique identifier. Okay, unique identifier. So each packet is given a unique identity, and this identity is represented here using these 16 bits. Now there are certain flags that are used to represent different scenarios in the packets, similar to TCP. This is the value that represents fragment offset. We will talk about fragmentation a short while. So offset value जो fragment की होगी, that it will indicate. Then time to live field. In short, we call it TTL. So this value is important because many times it may happen that due to some issues in routing algorithm, your packet may go into loops, and it may remain in the network for a long time, and we do not want this situation or this condition, because it will consume the bandwidth unnecessarily. We will talk about time to live field or the importance of this TTL value when we will talk about the routing. Okay, so this is very important field, and it actually this is the value that is around network dimension. For internet, around this value is around 15 to 16. Okay, this field represents the identity of the upper layer protocol. You know that internet protocol carries the data that is handed over by the TCP protocol or UDP protocol or any other protocol that is running at the transport layer. Okay, so this is the identifier that indicates which the data that is carrying, or the data part contains the data for which protocol. So this data may be of TCP protocol, it may be of UDP protocol, it may be of some other protocols at the network layer as also, like ARP, RARP. There are some protocols that also runs at the network layer. So maybe some network management protocol, maybe there IGMP, ICMP, whatever. So जिस भी protocol का data होगा, so that this value it will indicate the protocol actually. And now this is the checksum, that is header checksum. So this checksum actually is a checksum value that represents headers error correcting value bits actually. So these bits are used to detect and if there is any error into the header. Okay, now it is important to understand that this checksum is not used to check any errors into the data. Okay, this is only for header part. Now you see, these are the two important values. These are the obvious. If you write this description, you have a 32-bit source IP address. So this is the IP address that represents the machine's IP that have generated this segment, and this is the IP address that belongs to the destination machine to which this packet is to be delivered. Okay, then you will have options. Certain options are there. Okay, then you have here data. So this is the format of your IP datagram. Now let's talk about segmentation part, fragmentation and reassembly actually. Now let's try to understand first what is the fragmentation and what is reassembly. So fragmentation means obviously cutting the packet into pieces. That is called fragmentation. So it may be the case that you might have a large packet, maybe let's say 10 kb. Okay, and now it may be the case that you divide this packet into two packets each of 5 kb. Okay, so this kind of division of the packet into one or more packet is two or more packets is called fragmentation. Now so this fragmentation is generally done at some point. It may be at some router, it may be done at some router, and then these fragments at the receiving end or at the destination may be combined into original single packet. So suppose at some router divide these segments into this segment into two segments, and then these two segments will be combined by your receiver or destination in again back to the original segment. So this process is known as reassembly. Okay, reassembly. Now question arise होता है कि why we need to do fragmentation and reassembly, why it is required, or why it happens that a packet need to be fragmented, what is the potential cause for this. So actually what happens, you know that I have already told you that when a network layer has some packet to transmit, so it actually doesn't transmit directly. What it does, it creates header, puts the required values, and then handed over this packet to lower layer, that means data link layer. This is the similar to that job that is done by transport layer. Transport layer gives the segment to the network layer for transmission, and then what network layer does, network layer also also gives the segment to the data link layer. Okay, so data link layer is the actually layer that will do the transmission. So now you also know that when there is a path or a path is set up between transmitter and receiver. Okay, now suppose that this is a transmitter that transmits, or this is the sender that sends a packet. Now this packet may follow a path from source to destination. Now in between you will see that there are multiple links. There is one link from this network, this machine to this router, and then there is a link from this router to this router, and there is another link from this router to this router, you have one more link from this router to the router, and then finally you will reach to the destination. Now it may be, you also know that these links are of different nature. Some may be optical fiber, some may be Ethernet link, some may be wireless link, or and so on. Now it is also the case that since these are the different links, so obviously they may not support, or they will not support the same frame size. Now I have used the term frame. So actually data unit, or you can say that the equivalent to the packet frame at the data link layer, हम उसी पैकेट को या एक जो चंक बनाया है डेटा लिंक लेयर में, वी कॉल इट फ्रेम. ओके, so just टर्मिनोलॉजी का अंतर है. At transport layer we call the same, call it segment, then at data link layer we call it packet, and then at the link layer, data link layer, we call this unit a frame. Okay, so what frame will contain? Frame will contain an IP packet that is within it, and then some header that will be called field and frame. It will also have some trailer as well. So the frame, the size of the frame that this links permit will be different from this link and also from this link. So the size of the links that these frames may permit may be different. So for example, suppose let's assume for simple example, suppose this link supports only the frame size of let's say 2 KB. This link supports frame size of let's say 5 KB, and this link support the frame size of let's say 10 KB, and this supports let's say 3 KB. Now you see that suppose that's this the sender sends a packet of 10 KB. So now you see that let's suppose ये जो link है इसकी capacity 10 KB है, so there is no issue, but you see that this router which is using this link to forward the frame from here to here, so this link only supports the maximum frame size of 2 KB. So obviously you cannot send a segment of 10 KB in size using this link. So obviously what you have to do then, you have to divide your whole packet into 5, or whole frame of 10 KB into 5 smaller frames. Yes or no? So ultimately your segment, you can say that your data packet have been divided into 5 packets actually, 5 packets, and then 5 frames you will have. Then your frame may be transmitted. Here no division will be done, here no will be division will be done, here no division is required. So this is the region, that's why your packet is segmented. Okay, so this process is known as fragmentation. यहाँ पे आपने क्या कर दिया है, आपके जो फ्रेम है उसको मल्टीपल फ्रेम्स में डिवाइड कर दिया है. And reason is that in path you cannot transmit arbitrary length frame. There may be a link that will support only a small size, so आपको उसी link के according frames transmit करना पड़ेंगे. So now on this path the size is 2 KB, so we call it MTU, maximum transmittable unit. So the maximum transmission, हाँ
सर अपने पॉइंटर का साइज बढ़ा नहीं सकते सर, पता नहीं चलता है आप किधर पॉइंट कर रहे हो.
I also don't know how to increase the size of this pointer. Okay, I will try to find out, but अभी तो इतनी जल्दी मैं पता नहीं कर पाऊँगा.
Sir, when we are fragmenting the datagram packet, so what about the field of all the packets, sir? Fields, sir, they will contain the same fields.
Yeah, same field. Actually fragmentation will be done at the data link layer level actually. So your headers will be minutely modified. So some field obviously your packet will contain should contain the header. 5 pieces will contain the header, so some fields will be newly added. Actually format will be the same for the packet, but some entries will be new. We will talk about those things also. Okay, obviously your IP header need to be copied into the each of the pieces. जो IP header में जो header है IP packet में, that header need to be available into all those pieces. तभी तो उसके वो हो पाएगा, क्या कहते हैं, राउटिंग हो पाएगी. अदरवाइज राउटिंग नहीं होगी. जैसे लाइक सोर्स डेस्टिनेशन एड्रेस ये सब होंगे सेगमेंट में, but those fields some fields will be as it is and some fields will be having some modified values. Okay.
Yes.
So this frame size is called MTU, maximum transmittable unit. Okay, MTU. So for this path, for this example, your MTU is 2 KB. Okay, MTU is 2 KB. What is this? So now fragmentation, the एक पैकेट को कितने फ्रेगमेंट में डिवाइड करना है, इट विल डिपेंड ऑन द MTU ऑफ द पाथ. ओके, नाउ ऑब्वियसली जब आपने इसने एक पैकेट को 5 पैकेट्स में डिवाइड किया है, सो एट द रिसीविंग एंड ऑल दीज पैकेट्स नीड टू बी combined into a single packet. So this task is called reassembly. So for example, in this case you can see that there is a one packet which of this size, then this packet has been divided into 3 packets. In this example, diagrammatically they are showing, and then all these 3 packets will travel to this router, and at this point at the machine, receiving a machine, these all 3 packets will be combined by the receiver in a single packet. Now obviously it may be the case that you also already know that IP is a best effort delivery protocol. Okay, it doesn't guarantee any reliable delivery, and also it doesn't guarantee in order delivery. So your segments or the packets may arrive at the receiving end out of order. Now receiver need to then know or need to have a mechanism, so that need to have something or some information from the point node that is dividing the packet, so that receiver will be able to recombine the packet in a proper order. So at the point where fragmentation is done, that node ensures that each of the fragment will have a serial number. So that serial number will help the receiver to know or to organize or some information, not always serial number. Actually we will talk about that, वो serial number किस तरीके से है. एक they will have same identification ID, actually same ID will be there having, and then they will have information that will help the receiver to order those packets और proper order में combine कर पाए. ऐसा ना हो कि पीछे की बाइट्स आगे जाके कनेक्ट हो जाए, आगे वाली बाइट्स किसी और लोकेशन पर कनेक्ट हो जाए. बाइट्स का जो ऑर्डर है दैट नीड टू बी रिकवर्ड एट द रिसीविंग साइड. सो जिस ऑर्डर में पैकेट्स में बाइट्स थी उसी ऑर्डर में रहना चाहिए रिसीविंग साइड पर भी. तो वो ऑर्डरिंग के लिए देयर आर सर्टेन मैकेनिज्म. सो लेट्स सी दैट हाउ इट इज डन. Now as I told you that there were 2 fields that are available in your packet, that is fragmentation related field, which is called, one is called fragmentation offset. Let me come back here. This is the field that is used to do this fragmentation offset. So this field allows allows the receiver to reorder the packets at the time of combining them, so that packets में जो bytes का order है वो preserve रहे, original जो order है वो recover हो जाए. Here there are certain flags. मैं ज़्यादा सारे flags को discuss नहीं करूँगा, बस I am just talking about one flag. That is the flag that indicates the fragmentation. So this flag indicates whether packet has been fragmented or not. So हम अभी इसकी बात करते हैं. Now let's come back here. Now you see that there is a ID that will be used in this fragmentation part. Then you have a flag FRAG, FLAG. This flag indicates whether a segment is fragmented or not. Okay, so if this flag is 0, that means fragmentation is not done, and offset will be 0 then. But if this is, suppose a packet is fragmented, or it is a fragment of a original packet, then this field will contain 1. Okay, now let's take an example. From example you will be clear. Now suppose that original datagram or original packet that you are having, that was created by the transport layer, is of let's say 4000 bytes. So original जो पैकेट आपका 4000 बाइट का है. ओके, एंड अज्यूम दैट MTU जो है पाथ का, जो this is the path between sender and receiver that need to be used for transmission purpose. So ये जो path है जिसे follow करना है, this path having MTU of 1500 bytes. Okay, so obviously you know that you cannot send a segment of more than 1500 bytes on this path. So what you have to do, you have to divide this packet into how many packets you will divide. Obviously you see पहले बाइट में, अच्छा एक चीज़ और ध्यान रखना है, हेडर का जो वैल्यू है 20 प्लस 1500 है ना, तो हाउ मेनी डेटा विल बी देयर 20. आई एम अज्यूमिंग दैट देयर इज नो ऑप्शन प्रेजेंट. सो मिनिमम हेडर साइज इज 20. तो 20 हेडर होगा पहले पैकेट में, एंड हाउ मेनी डेटा यू कैन कीप देन इन दिस सेगमेंट, this much of byte. So this will be your header part, size of the header, this will be your data. So in each segment you can have this kind of arrangement: 20 byte header, 20 byte data. So because you are allowed to only keep 1500 bytes in a segment. Okay, so how many headers you will how many segments now you will have for this size? 3. अगर आप देखें तो 1500 प्लस 1500 प्लस रिमेनिंग जो भी है ना. नाउ इसमें भी आपका 20 बाइट होगा. सो और एक्चुअल डेटा कितना होगा? 20 प्लस 3980 बाइट. सो ये आपके डेटा होगा, 20 बाइट हेडर होगा. Okay, you will have 20 byte header and this much of data, this much byte of data. Now you want to divide these, so obviously you can you will generate 3 packets or 3 packets from this size of data. So in first packet you will have 20 byte of data, then 20 byte of header and 480 bytes of data. So
1418 फिक्स्ड है सर. डेटा की साइज
क्या
सर? डेटा की साइज
हाँ
4080 है जो.
हाँ 1480.
यस सर.
Because your MTU is 1500, so you cannot have more than this data. So 1500 ही बाइट रखने हैं, तो आपका 1500 बाइट में क्या हो जाएगा? 20 बाइट का हेडर रखेंगे आप और दिस मच ऑफ डेटा, क्योंकि सेगमेंट का साइज इससे ज़्यादा बड़ा नहीं हो सकता आपके पैकेट का. जो ईच पीस बनाएंगे जो आप, यू आर डूइंग फ्रेगमेंटेशन नाउ. सो कितने पीस बनाने हैं वो आपको देखना है. सो पहला जो फ्रेगमेंट होगा उसमें 20 बाइट का हेडर, ये डेटा होगा. सो लेट मी राइट लाइक दिस. देन अगला 20 बाइट प्लस फिर 1480 बाइट, देन प्लस कितना होगा ये? 1480 कितना हो गया? 2960 है ना. 0016 4489 2960. सो 2960 आपका डो में आ गया डेटा. हाउ मेनी डेटा नाउ यू हैव लेफ्ट? 3980 टोटल डेटा है. यू हैव 2. ओके, सो जो थर्ड सेगमेंट होगा उसमें आपका लेट मी रीचेक 0 2 0 and 1. ठीक है, 102 है. सो effectively you will have 3 segment. This is the segment 1, this is your segment 2, this is your segment 3. Okay, so now let's see. So your packet will be divided into 3 smaller packets, जिसे हम fragments बोल रहे हैं. So you will have 3 fragments. Now each of the fragments will have these lengths. Okay, 1500, this much, this much. Okay, now as I told you that since you need to tell, or receiver should have an idea, or receiver should have a way to know whether these fragments, these are the different independent packets or these are the fragments that have been generated on using a single packet. So रिसीवर को ये इंडिकेट कराने के लिए ये सारे फ्रेगमेंट्स एक ही पैकेट के हैं. व्हाट यू विल डू, यू विल यूज सेम आईडी वैल्यू इन ईच ऑफ द फ्रेगमेंट. सो आईडी की जो वैल्यू होगी, ओरिजिनल पैकेट में जो आईडी है, लेट्स से दिस इज एक्स, सो ऑल पैकेट्स विल हैव दिस आइडेंटिटी एक्स एक्स एक्स. सो ऑल दीज 3 पैकेट्स P1 P2 P3 जो भी हैं, ये सेम आईडी कैरी करेंगे. ओके, इस तरीके से. देन फ्लैग की वैल्यू क्या होगी? फ्लैग विल कंटेन 1. So this value will indicate that this packet has been fragmented. So that means you are receiving, when receiver will receive this one, so receiver will know that this packet जो receive हुआ है ये एक fragment है. This is not the complete packet. You receiver will know that I have received a fragment, not the complete packet. Similarly, this field is also indicating that this is a fragment, and then this is indicating that here 0 indicating this is the last fragment. ठीक है, जो लास्ट फ्रेगमेंट होगा उसमें 0 होता है, इसका मतलब देयर इज नो फर्दर फ्रेगमेंट आर देयर. नाउ देयर विल बी ऑफसेट वैल्यू एज वेल. आपके जनरली ऑफसेट जो है ना, एक एम्प्टी वैल्यू होगी अगर फ्रेगमेंट नहीं होगा तो। ओके, नाउ इफ ऑफसेट इज जीरो, हियर देखेंगे यू कैन सी दैट जब पैकेट फ्रेगमेंट नहीं होगा तो दिस फ्लैग विल बी जीरो एंड ऑफसेट विल बी जीरो। सो जब फ्लैग जीरो है तो ऑफसेट की वैल्यू का कोई मतलब नहीं है, इट इज जस्ट अ गार्बेज वैल्यू। बट इफ यू हैव फ्लैग इज इक्वल टू 1 देन ऑफसेट है, इसका मतलब दिस इज a valid offset value, so this flag makes it valid. And you see this is 0, so 0 offset means this is a first segment, ठीक है। and this offset value will help the receiver to know इनमें से पहला सेगमेंट कौन सा है, सेकंड कौन सा है, एंड सो ऑन, और उसी ऑर्डर में फिर वो कंबाइन करेगा। so now you see here offset is written 185, so how it is 185, just divide this length, इसमें कितनी लेंथ थी, सो 185 डिवाइडेड बाई 8, सो इसका मतलब है इससे पहले 1480 बाइट्स जो थी वो आपकी ये आगे की बाइट्स हैं, एंड दिस इज इंडिकेटिंग दैट दिस इज नेक्स्ट बाइट आफ्टर 1480। ओके, सो दिस इसमें जो बाइट्स हैं उसका नंबरिंग आप कहाँ से शुरू करेंगे, 1481 से लेकर के एंड सो ऑन। सो यू कैन से दैट ईच बाइट इज हैविंग सम नंबर। यहाँ जो बाइट्स हैं उनकी नंबरिंग क्या होगी, जीरो से लेकर के सो जीरो से शुरू हुए 1479 होगा, यहाँ की जो पहली बाइट है, पहली बाइट का एड्रेस होगा 1481, 1482 एंड सो ऑन। ओके, सो दिस ऑफसेट इज इंडिकेटिंग और एक्चुअली गिविंग ए काइंड ऑफ आइडेंटिफिकेशन टू ईच ऑफ द byte into the fragment. Okay, and in third you see offset is this one, so total bytes इन दोनों का सम जो होगा उससे 8 से डिवाइड करके आपको ये सीक्वेंस मिल जाएगी। सो दिस ऑफसेट विल इंडिकेट द सीक्वेंस नंबर ऑफ दिस बाइट, आप इसे 8 से मल्टीप्लाई कर लीजिए। सो इसका मतलब वो समझ जाएगा इससे पहले 372 into 8 नंबर ऑफ बाइट्स अवेलेबल हैं। सो दीज आर द टू प्रीवियस फ्रेगमेंट, दिस इज द लास्ट फ्रेगमेंट। सो दिस ऑफसेट हेल्प्स एक्चुअली द रिसीवर टू नो द ऑर्डरिंग ऑफ दीज पैकेट्स। ठीक है, अगर सेगमेंट है तो सेगमेंट क्या करेगा, सीधा इनको ऑफसेट्स के ऑर्डर में अरेंज कर लेगा पैकेट्स को, एंड ऑफसेट के ऑर्डर में आप कंबाइन कर लीजिए, एंड देन यू कैन गेट द ओरिजिनल पैकेट एट द रिसीविंग एंड। ओके, सो रिसीवर इनको ऑफसेट के ऑर्डर में कंबाइन कर सकता है। यू सी दैट फर्स्ट सेगमेंट विल हैव स्मॉलर ऑफसेट, सेकंड, सो अगर आप इनको ऑफसेट के ऑर्डर में भी सॉर्ट कर लेंगे और फिर कंबाइन कर लीजिए डेटा, यू विल एबल टू जनरेट गैदर द ओरिजिनल पैकेट। ओके, और कौन सा फ्रेगमेंट सेम पैकेट के हैं वो आईडी से आप पता लगा लेंगे। हाँ
सर, कैन वी से इट इज डिसाइडिंग और इंडिकेटिंग द पोजीशन?
या दिस इज ए पोजीशन इंडिकेटर। लेकिन ये जो नंबर है इसको छोटा कर दिया गया 8 से डिवाइड करके।
यस,
ठीक है, नहीं तो बाइट नंबर लिखना पड़ता आपको। ओके, गॉट इट। सो दिस इज हाउ the fragmentation will be done, and at the reassembling side, receiver will just see that these segments having same id. Okay, so receiver know these fragments are belonging to a single packet, so in मतलब इनसे single packet बनाना है receiver को। now what receiver will do, it will see offset is 0, that means this इसमें जो data है उसको सबसे आगे रखना है यहाँ पर। let's say this is the data that is coming from this segment, then this fragment, sorry, देन यू नो दैट नेक्स्ट फ्रेगमेंट वैल्यू क्या है, 185। इसके बीच में कोई फ्रेगमेंट नहीं होगा, या आप देखेंगे इसमें उसको मालूम है कि इसमें फ्रेगमेंट की लेंथ कितनी है, मैक्सिमम है। सो आप इसको ये जो फ्रेगमेंट है इसको 8 से मल्टीप्लाई कर लीजिए। सो दिस इज द नेक्स्ट फ्रेगमेंट एक्चुअली। ओके, सो इट विल कंबाइंड दिस फ्रेगमेंट टू, जो इसको भी डेटा को जस्ट इसके साथ कंबाइन कर देंगे। सो दिस इज और 2 पैकेट्स कंबाइंड हो गए, एंड देन अगला इसके इमीडिएट फ्रेगमेंट है 370, सो इसके डेटा को कंबाइन कर लीजिए 370। सो आपको फिर ओरिजिनल जो है ना 3980 का जो डेटा है वो रिकवर हो जाएगा। यू विल रिक्रिएट ए 20 बिट हेडर हियर। ठीक है, जो कॉमन फील्ड से उनको अब इनको ज़रूरत नहीं है असेंबलिंग में, आईडी तो रिक्वायर्ड है, सो यू विल कॉपी द आईडी एंड यू विल मेक द फ्लैग्स अकॉर्डिंगली। सब फ्लैग्स को एक ही फ्लैग की वैल्यू रहेगी, अब इसमें जो भी फ्लैग होगा उसे वापस 0 कर लेंगे, एंड ऑफसेट को कोई मतलब नहीं है। नाउ जैसे ही फ्लैग 0 होगा, ऑफसेट इज ए गार्बेज वैल्यू, आप उसे कंसिडर नहीं करेंगे। offset is only considered when this flag is 1. ठीक है, okay, so this is how reassembling fragmentation and reassembly will be done. Any question?